Hello everybody and welcome to a chat from the engineering desk. Today we're talking a mechanical topic, something very interesting, very relatable, something that's going to be easy to follow and understand, and going to be interesting. We are talking about the power steering in automobiles. In this case it's a power assisted hydraulic rack. So what I did is I designed a crude 3D model this morning. It's not entirely anatomically correct, but it's an accurate representation of what the hydraulic rack in an automobile is, a car. So let me go over the components here. There's a steering wheel inside the vehicle. Then you've got your rack assembly over here. Now what's not shown over here is the pump. And you've got a pump on the engine that supplies oil to the rack, and then there's a return line to the pump, which has got a reservoir on it. So that line goes to the reservoir. The pump draws from the reservoir and makes fluid under pressure available to the rack via this line in the direction that arrow is pointing. Alright. So inside the rack you've got three fundamental components, four actually. You've got the spindle, which has got a helical pinion on the end of it. And that's important for a very specific reason. You've got the rack, which it meshes with, not as I've drawn it, but it meshes with it. Then you've got the spool valve, which controls the flow of oil for the hydraulics, and then you've got the cylinder, which is where the oil pushes against the piston to move it left or right. So what happens when you turn the steering wheel is that you got the force of the wheels holding this rack. This is connected to the tie rods, which is connected to the front wheels. That's what moves the front wheels from side to side. So that's the plane where the tie rods are on. So it's connected to them. So when you try and turn, you exert a force on this rod. Now because you got the resistance from the wheels to being turned, this doesn't move very easily, which is why we got power steering. The result of this force is that this pinion, which is engaged on the rack, which is free to move on the vertical axis, now actually slides on the rack. So if you were to turn left, the pinion would rotate that way, and it would move. It would move upwards. So what's going to happen then is that this spool over here is going to move upwards. So pressurized oil is now going to flow through there to there into that chamber over there, applying pressure to the piston and moving the whole assembly, the rack and the rods to the left. That's going to pull the wheels to the left, and you're going to turn left. Now what happens as that rod moves? You've turned the steering wheel the amount that you want to turn. So now it's stationary. So now that valve's open. So the rack moves to the left, and what happens is that it now causes a spool to move in the other direction and return to this position again. and then the flow of oil to there stops once it has reached its neutral position. So it's helped you to move the wheels to the left. Now during this operation, the valve has exposed this port to return to reservoir. So the oil on the other side had been pushed back to the reservoir. So if you turn to the right, what is going to happen is that this is now going to move down. What's going to happen is that that port is now going to be exposed to oil from the pump. Now this spool valve is incompletely drawn, but you'd have a couple of ports. But now you're going to have pressurized oil on this side of the cylinder, pushing on the piston from that side, pushing it the other way. And the oil's going to return here to the reservoir. And then as it moves, the spool's going to once again move till the ports are closed, and then the rack stops moving in relation to the input that you gave on the steering wheel. So just spinning it around there, you can see how the helical pinion engages on the rack. I've got it centered on it. It's supposed to be on top, but never mind. The rack has got a seal here and a seal here. That's what keeps the oil in these two chambers. And then you want a piston over here, which has got a seal around it as well. The oil can't flow from the one chamber to the other because of that seal there, and it can't escape the rack because the seal's at that point over there and that point over there. Now when your rack develops a leak, it's one of these seals that has failed, or possibly a seal on this assembly over here on the spindle. That's what it looks like. So when you see a rack lying on the ground and you wonder why the shaft that goes to the rack is not at right angles to it, it's because of this helical pinion, because it's got to move up and down to work the spool to control the flow of oil. And in relation to the movement of the rack, it also moves up and down to control the flow of oil. And that's how power steering works. Nice and simple. Very effective. And I've been talking for long enough. Thank you very much for joining me here today. This was an interesting one. Hope you learned something, found it interesting. Hope you'd like to comment below with your thoughts on this. Maybe give it a like, maybe join the channel. Make sure that you've hit the bell icon for notifications when I upload. If you do join, please feel free to do so. And for the rest, have an awesome day further. See you here for more videos. Cheers.